It's long been recognized that doing lots of high-precision blood tests from a blood sample small enough to be drawn at home at a very low cost is the holy grail of blood testing. The transformative and disruptive potential of this type of blood testing is well understood. Accordingly, much effort has been expended in searching for this holy grail. Many projects have been marked by lots of hype and enthusiasm. Most have not lived up to the hype, and most have largely failed. Even before the epic failure of Theranos, the most heralded of these projects, this space was littered with the corpses of many projects, large and small, that disappointed. It's in this well-worn space that we've been toiling. Early in this project, we sought to learn from foremost experts what the barriers are that chronically thwart these efforts. We learned that the biggest barrier is the vast, dynamic range of blood. It's like this. Scientists speculate that there are as many as 10,000 different kinds of proteins circulating in blood, only 2,000 of which have been detected. When you order the list of these proteins by abundance, albumin is at the top. About 50% of all proteins in blood are albumin. And the top 20 most abundant proteins account for about 99% of all proteins circulating in blood. It's not difficult to test for any of these 20 most abundant proteins, but the proteins further down the list can be very difficult. It's a lot like finding needles in haystacks. In the case of interleukin-6, a low abundance protein of interest, for each interleukin-6, there are about 10 billion albumins. Clever biochemical methods have been developed to remove these high abundance proteins preferentially. The best available will remove up to 99% of these albumins, but that just makes smaller haystacks. For every interleukin-6, there are still 100 million albumins. The needle in haystack phenomena blocks most every pathway to blood testing's holy grail. Accordingly, our pursuit has focused on how to isolate the needles from the hay. We have now demonstrated and patented the complete isolation of protein residues of interest from the high abundance protein content of blood. We employ a unique basis for isolation that had not been obvious to foremost experts. With it, we have opened new pathways toward achieving blood testing's holy grail.